what we have to talk about are statistics, like I was just saying. And statistics, what that has to do with is basically it's the study of data and the properties of said data. Studying data and drawing, oh, let's say it this way, study of data and organizing and summarizing, and even get to the point you can draw conclusions about your data. More or less is what we mean by statistics. So we're talking about data, collecting all sorts and kinds of data. Now, usually, unless you have a small group of people or things or whatever it is you want to get statistics on, unless you have a small group, usually you want a sample of the group. You don't, like if I'm trying to figure out who's going to win the election for this year, I can't go out, if I'm talking about before the election, I can't go out and find every person and ask them who they're going to vote for. For one thing, they may not vote, but for another thing, it's just impossible to do the whole group. So yeah, we want to come up with a sample that represents the group at large. And what we try to strive for is a random sample. That's the best type of sample you can get. And of course, what I mean by a random sample would be a sample that where every person or everything would have an equally likely chance of being picked. You know, if I handpick certain people, I may not get accurate results. If I say, well, I'm going to ask only this such and such a group, well, you miss out on the other. So you try to get a random sample. It's not all the time able. You're not all the time able to get those, but that's what that's what you strive for. Now, we'll distinguish here between two types of statistics. There are descriptive statistics and there are inferential statistics. In descriptive statistics, well, that just as the name suggests, these are statistics that describe the sample or population that you're studying. You know, what is the average value? What different things. We'll talk about a few of those here. The inferential statistics, that has more to do with the drawing the conclusions. What does the data seem to suggest about the population at large? We won't do much of that. If you take a statistics class, you'll get more into the inferential, but we just have time right now to talk a little bit about the descriptive side of our statistics. So anyway, just recognize or note that there are two different types. You can distinguish between those two types. Okay? All right. Well, where we start is with what are called measures of central tendency. These are, again, descriptive statistics, and we'll group them kind of in categories. These are measures of central tendency. The idea being we're trying to find kind of a value, a representative value for the group. And we've got all this data. How can we kind of summarize it with a representative value? Well, If you think about it, a good example of the first one that we want to talk about, the first measure, there's three of them we'll talk about. If I was, if you were, say, teaching a class, or just think about what I do anyway, as a teacher, if I'm looking at how my class did as a whole, what kind of statistic do we usually look at? Look at the average, right? Or, how did this person do in this class? Well, we look at their average percent, what their percent average is for the class. So average is one of these so-called measures of central tendency, because that kind of gives you a middle of the road value, right? So that's the first one. Now, in statistics, the average is also known as what's called the mean. So number one measure of central tendency is the mean. But by the mean, again, in statistics, that just means we're talking the average. The mean is just the average of all the values. Okay, well, let me throw a little bit of notation here at you. Average, what do we do? How do we calculate the average? Well, if I've had a class of 30 students, I would add up all the 30 scores and divide by 30, right? So the mean is equals, it's the sum of all the values divided by total number of values. With me on that? Sum of all the values divided by the total number of values there are. Like I said, 30 students, so add up all the test scores for that particular test and divide by 30. So we call it average usually. Statistics, they usually call it the mean. Okay? Now, let me throw some notation here. The mean is typically, statistics-wise, denoted X bar. X with a bar on top of it. And I usually read it X bar. I think a lot of people read it that way. But that means the mean. Okay? The mean is X bar. Now, let me also throw this notation at you. Has anybody ever seen that symbol? Probably not. You may see it on some calculators too, but the mean can be described this way. This symbol here, if you ever see it in mathematics, usually means sum. The summation symbol. So what this notation here means is I want to sum up, that's an X, so I want to sum up all the X's. Sum of all the values. That's what this means. So it's just a notation that it means the same thing as that. Okay, and then what I'm going to divide by is n. And let me just tell you right there, divide by n. N is the typical way in statistics to denote the number of values there are. So we'll see that a couple of times throughout here. N, you see n in statistics, that typically means the number of values there are. Okay? Now, you may not have to write that notation again, but I just wanted to show you a couple of things there. There's your mean formula, but don't let that confuse you at all. It's the sum of the values divided by the total number of values there are. Okay? So if I had, let's say I had 16, 18, 22, 36, and 45, what is X bar there? What's X bar for that? 16, 18, 22, 36, and 45. What's my X bar? How would I find it? Well, X bar is the mean. the average. So what would I do? I would take the sum of all those values, add up 16, 18, 22, 36, and 45, right? Add those all up, which gives me 122. Huh? Is that what you said? 40, 56, and... oh, no, 56 plus 70, 81. Yeah, 137. I get 137. Okay. 137, and then we divide by what? Divide by 5. 5 values, so we divide by 5. So 137 divided by 5, we're going to get a nice little decimal, 27.4. And what does that represent? It's kind of a middle ground value of these particular values. One other little thing too, if we put these on a number line, you may not know this about the mean, but if we put like a coin, had a number line stretched out, and put a coin at 16, at 18, 32, at 22, at 36, and at 45. If I put a coin on each one of those on this stick, where do you think the balancing point would be? It would be at the mean. The mean is a balancing point of all these values if you were to construct a little experiment like that. So that's just another little side note. I may use that more in just a second. But anyway, all right, so that's the mean. But there are three of these central tendency. That kind of gives you a central number. You think of another one that kind of a central number value. Number 2 is a median. And by definition, what's the median? Somebody knows, right? The median is the exact middle value. If I have 4, 8, 9, 13, and 22, the median is the one that's right in the middle. 9 in this case. That's the median. Another way to look at it, the median, it's the value where you have equal number of values less and the same amount more. So it splits the data kind of in half. This side has 2, that's in this case has 2. That's the median. It's the value right in the middle. Now, you do run into a slight problem on some of these. What if I had, that one had 5 values, what if I had 6 values? What if I had 7, 11, 14, let's do 17, I want to do 6, all right, 20, 21, and 31. What's the median going to be right there? Well, the problem I run into there is I can't choose 14 because it has 2 and 4, right? And I can't choose 17 because it has 3. Oh, I'm sorry. Okay, never mind. Let me take that one out. All right. 7, 11, forget the 31. Forget the 31. Forget the 31, okay? And so now I can't choose 14 because I have 2 and 3. I can't choose 17 because I have 3 on this side, 2 on that side. So what you have to do there, what do you do there? Yeah, you take those two and add them and divide by 2. Yeah, you average the 2 in the middle. $15.5. 15.5. So that would be the median of those two there. Okay. Now, one other thing about the median. let me just say, let's say I had, oh, let's go with 5, 12, 22, 6, 17, 13, and 9. What's the median there? Is it 6? Why is it not 6? Well, what we're saying is you have equal, less, the same amount less as you do more than that number. However, 6 only has one value less, right? If you put them in order here, 6 only has one value less. The rest of them are more. So it's not dividing it up. Technically, this 6 is not dividing it up where you have this many, the same amount as greater than as you do less than. So the point on this I'm trying to make is be sure to put them in order when you're doing the median. Because not always do these lists come in order. You want to order them if you want to find the median, the best way to do it. All right, so what do we got? 5, 6, 9, 12, 13, 17, 22. Did I do those right? 1, 2. I think you got them all. So what's the median? 12. Okay? So yeah, putting them in order, best way to go. Now, the mean, does it matter the order? No. The mean, it doesn't really matter the order, but it is helpful most of the time to put them in order. But the median is definitely one where you'd want to put them in order before you decide. Now, here's another thing on the median. So far, I haven't needed it, but there is a little formula for the position of the median. Let's talk about that. Do it right here so I can leave these up here. Now this tells you the position of the median, not the actual median itself. It tells you where it is. The position of the median goes like this. It's n plus 1 divided by 2. That'll give you, if you have a longer list, that'll give you where the median is. Now, what did we say n was? N is the number of values. So you take the number of values plus 1 and divide that by 2, and that'll tell you which position the median is in. For example, if I did that formula for this list, I would get the position of the median to be, I've got 5 values, so it'll be 5 plus 1 divided by 2, so that'd be 6 divided by 2, that's 3. So the median is in the third position. Which position was the median in there? In the third position. Works the same thing here. I've got 7 values, so position of the median, that would be 7 plus 1 divided by 2, that's 8 divided by 2, so that's 4. Fourth position, which is exactly where 1, 2, 3, fourth position. Okay? Like I said, you don't need to do it on those smaller lists, but in a moment we will use it. Now, what happened here? Well, notice here, if I do the position, hit that one, I would get, what have we got? 6 plus 1 divided by 2. That gives me 7 divided by 2, which is 3.5. 3.5 fifth? 3.5? Yeah, that's what it was, wasn't it? Because that would mean between the third and the fourth, right? Here's the third, here's the fourth. The median is in the middle of those. So if you get a decimal 0.5 one, it just means take the one before it and after it and average. Okay. So hold on to that little formula. We may come back to it in a moment. All right. So what we need to do is talk about the third component installment here of the measure of central tendency. Yeah, the median is definitely a central value. Because it's the one right in the middle. But there is a third one. And that third one is even simpler than those two. It's called the mode. What is meant by the mode? The most frequently occurring value. It's the one that occurs most. Mode for most, right? Mode is the most frequently. So if I had, none of those had duplicates, but if I had some duplicates, say 2, 2, 3, 3, 3, 6, 6, 7, 8, 9. What's the mode? Mode is 3. Because it occurs 3 times, this one occurs twice, those are only once. So yeah, the mode is the most frequently occurring number. Now if I had, say I had 11, 11, 12, 12, 12, and 15, 15, and 16, 16, 16, what's the mode there? Well, I have 12 that occurs 3 times. I have 16 that occurs 3 times. This one has 2 modes. Modes. Yeah, you can have 2 modes. If one value occurs the same amount as another and it's the most frequent one occurring, you can have 2 modes. But that is the limit. You can't have more than 2. Cannot have more than 2. What happens? 2 modes. Rule of thumb there. What happens if I have more than 2? All right, so let's go back to this one. What's the mode there? Well, they all occur one time. None of them occurs any more than another. So there's no mode.